When you ask most people how we find planets, they would probably guess that we just look in a telescope and find them. And guess what? That is possible. In 2005, for the first time ever, we used the Spitzer telescope, which is an infrared telescope, looking at the heat signature of an exoplanet, the easiest to find. So we can use this really pretty well for what we call hot Jupiters, big gas giant planets that are really close to their host star. What we need to really directly observe planets in the future is what you might call a SIM, a space interferometry mission. As you may recall, interferometry means combining more than one telescope. So imagine instead of one Hubble telescope, having 3 or 4 or 5 Hubble telescopes together in space, working collectively as one giant telescope. That's what it's going to require to actually see these things directly. But anyway, we were able to do it in infrared here in 2005. You see this big bright thing in the middle is the star. And that little fuzzy dot at the top of the screen right there, that is the exoplanet that they discovered. That would be a very hot Jupiter right there. Very big planet, very close to its star. So what about normal pictures? Well, this was done for the first time with a combined effort from the Keck telescopes and the Gemini telescopes. There's a Gemini north and south, and there's 2 Keck telescopes in Hawaii. And they did this for the first time in 2008. To get an actual picture of a planetary system, and they actually captured 3 planets at once. Now look at the masses of those planets. We thought Jupiter was a heavy planet back first semester. Look at those monsters. 7 to 13 times the mass of Jupiter. That's pretty incredible. Those are some heavyweight planets right there. The star itself is nothing special. Look at that, only 1.5 times the mass of our sun. So it would be a star not that different than our sun, but it has some really monster planets. This one's 130 light years away. That's actually, relatively close, kind of in our neighborhood, and towards the constellation Pegasus in the sky. Now, the same week they came out with that picture from the Gemini Keck team, the folks running the Hubble telescope came out and said, oh, we can do that too. And so they took a picture themselves of a planet. This one's around a pretty well-known star called Fomalhaut. It's actually one of the brightest stars in the sky. You probably are not familiar with it because it is a southern hemisphere star, but it's one of the brightest stars in the southern hemisphere, 16 times the luminosity of our sun. So it's just naturally a very, very bright star. And they were able to find a planet around this star that's 3 times the mass of Jupiter. Again, pretty monster planet there around Fomalhaut. This one is really close, 25 light years away, in the constellation Pisces Australis, the southern fish, not the same Pisces that's in our zodiac, the Pisces Australis in the southern hemisphere. This is the very strange picture that they took. Let me explain. They had to use something to block out that super bright star. Most of this, what you're seeing on the screen, is just kind of noise. Just you can ignore it. If you just look at the little box right there, that's all that really counts in this picture. Because in that box, when they zoomed in, they see a dot. And unlike the background stars, that dot is moving. And they realized that that was a planet orbiting Fomalhaut, very far away from it. Look at that. Look at the scale there. That from there to there is 100 AUs. Now, as a reference, Pluto is 39 AUs on average from our sun. So this thing is really far out there, this big planet. Really interesting. Obviously much different than our solar system. And there they are, those 3 little dots are planets. And again, they use some kind of weird filter here, the 3 planets, and then that weird thing in the middle is the star itself. And this shows the direction that they orbit that star that, again, is blocked out by some kind of strange filter there. Here's one of the systems we found that's been very interesting, Gliese. And you see Gliese 581 is the name of the star, so it has B, C, D, and E, these different planets there that we found. And you notice it's, first of all, this little swath down here, it looks like a sliding board, that's the habitable zone. For our sun, here's Earth sitting right in our habitable zone. For this star, the habitable zone is closer to the star. Well, that's because it's not as hot as our sun, so you have to be closer to be warm enough as a planet to have liquid water. And look at that, 581d is right on the cusp there. There's 581d, and seems to be right on the edge there of the habitable zone. That's exciting stuff for 581d. Now check this out. We're going to take a trip now to another multiple planet star system. We're going to go in our spaceship here towards the direction of Cancer the Crab. And here we go. We go up through the atmosphere here. And then we're going to, I believe, roll through the solar system for a moment here. There's Mars, the asteroid belt, Jupiter, Saturn, Uranus. Boom, we hit the light speed, I guess. And here we are, our warp speed. And we get to this system. And again, there are no real pictures yet of exoplanets. So they're just basically making them all look like Jupiter and Neptune and things like that because that's what we have to go by so far. We don't know exactly what they look like. It's probably a pretty good guess. We know they're gas giants, based on their density. So we go through all of them right here, but now they're going to go back. You get to this really kind of a hot Jupiter here close to that star. Now they're going to back up, and here's where it gets exciting because they're going to put in a little green disk here, which is the habitable zone. And so look at this. You've got this gas giant planet, and it's going to be sitting inside that habitable zone. That's where it gets exciting. Now, we don't expect to find life or complex life in a gas giant, but hey, if that gas giant has moons, large moons, like in the movie Avatar, they're not on a planet. When we find the Na'vi in Avatar, they're on a moon that's orbiting a gas giant planet. And so that could be the same thing. You could find life on a large moon of a planet orbiting in the habitable zone of its star. Another method that is used, it's used rarely, but it's very fascinating, takes advantage of Einstein's general theory of relativity. Einstein says that when a mass is sitting in space, a planet or a star, it warps the space around it. And so what can happen is, let's take a look at the picture at the top of the screen. You see the source star is in the background, and its light is being stretched around as space is bent around this nearby star. The light goes around it in different ways because it's warped. But here we have an exoplanet as well, and we can actually detect that extra warping there. The light changes its path enough that we can tell that a planet is there. So it's very advanced stuff. Very fascinating. So they used this for the first time in 2006. Again, fairly recent development there. And it's shown some potential. They found a very small planet, only 5.5 times the mass of Earth, using this method. And they have shown they can actually find more than one planet at a time. So I don't know if this is quite up to date, but at one point they had found 6 planets this way. Again, that's a pretty small drop in the bucket, but at least it gives us another way to try to find exoplanets. Pretty neat stuff. Just like the transit method, though, it has to be lined up just perfectly for this to work. In this case, we'd have to have that background star here and the closer star lined up with us just right, and the planet lined up just right for us to be able to use this method. Thanks for listening.